Hello everybody, this is Michael. In this video, we will talk about the FPGA Piano 02, make the buzzer buzzing. Okay, so the first things I like to talk about a little bit why we choose the buzzer as our FPGA piano audio devices. As you know, the buzzer is very cheap and easy access, so we can get the buzzer easily from anywhere. Okay, so for the buzzer, it has two types of it. The first one is the active buzzer. The second one is the passive buzzer. Okay, for the active buzzer, it has internal oscillator, and for the passive one, it doesn't have one. Okay, so because the active buzzer have this one inside it, so it can and only can produce the fixed pitch. Okay, if you apply one DC voltage, it can produce only one fixed pitch. But the passive buzzer, it can produce different pitch if you apply different frequency on the buzzer. Okay, so for the active buzzer, the price is high, and for the passive buzzer, the price is low. And we choose the passive buzzer for our audio devices. Okay. Okay, so next step, let's take a look at our schematic for the buzzer. Okay. So this is our schematic. This is our buzzer. This is our buzzer. So if we apply different frequency on this pin, the buzzer will produce different pitch, will produce different tone. Okay, difference. So produce different tone. So how we coding and for this pin. Okay, so let's take a look at our code. Okay, so this is our code. This is the buzzer. Okay, this is buzzer for the FPGA piano project. Actually, it is a clock divider. Okay, for the buzzer. So this is the input clock. For our FPGA board, this input clock is 50 megahertz. Okay, this is our FPGA board crystal frequency. Okay, this is input reset. This is control output. The control output will control the buzzer. Okay, will control the buzzer. Okay, and this is the count value. We make it a little bit bigger range. Okay, big range, because we need to adjust the frequency to control the buzzer produce different pitch. Okay, here basically is a clock divider. So when the system is reset, the system reset is low level reset. Okay, this is N means low level reset. Here we need to reverse the value so we can get the reset system inside the if. Okay, so this is reverse the value, and here we initialize our control pin and our count value. Here we will continue to count this number and then reverse the control level on the buzzer pin to produce different frequency. So why we choose this value? Okay, why we fix this one? In our example, we test it is 1K Hertz. We try to produce 1K Hertz for the buzzer to see the buzzer what sound the buzzer will produce. Okay, so we apply 1K Hertz on this pin. So why we setting this value and then we can get 1K Hertz. Okay, so for the clock divider, as we say, this code basically is a clock divider. For the clock divider, we use this function to calculate the count value. Okay, so this is input frequency. This is output frequency. The input frequency divided by output frequency, and then divided by 2 and minus 1. Why need 2 divided by 2? Okay, so for the count value, here is the high level and here is the low level. The count value only keep the high level or low level. After the count value arrive certain value, okay, arrive certain value, it reverse the level. It reverse the level. So we need to divide it by 2. And why we need to minus 1? Because the count value begin with 0. Okay, begin with 0. So according to this function, okay, according to this function, we calculate this value. So in our input clock is 50 megahertz. It will be like this. Okay, this is 50 megahertz divided 1K. This is 1K hertz, and then we divide it by 2. Okay, so we calculate this thing first, and it will be 50,000 divided by 2, and it will equal to 25,000. Okay, so this is 25,000. Okay, so here is 25,000 and the minus 1 will match this function. Okay, we'll match this equation here. By this way, we will produce 1K Hertz on the buzzer control pin. Okay, if our input clock is 50 megahertz. Okay, so this is our buzzer code. The next step, we will do the simulation for it. We need to create the test bench to simulate, to see whether can get the 1K hertz on this pin or not. Okay, so this is our test bench code. Okay, here is time scale. This is the clock period. This is 20 nanosecond. Okay, because this here is nanosecond. So this is 20 nanosecond. The 20 nanosecond means the clock is 50 megahertz. 10 nanosecond is 100 megahertz. Okay, so this is the module test bench. This is a module test bench. Here, this is the test target. This is the test target. And this is the input clock, input reset, and output control. This is a variable defined. For the input variable, we divided all register. And for the output, we divided while type. Okay. Here, we generate the input clock. Here, we generate the input clock. So this is initial clock at high level, and after every half clock period, we reverse the clock signal, so we can get the 50 megahertz clock. And this is the test flow. It's very simple. We just initiate the clock at 0 and reset the system. The reset signal make it 0, so it will reset the system. And after one clock period, we finish the reset, make it 1, and the system and the code will run this part. Okay, the code will run this part, and if the system reset, it will run this part. Okay, so this is the test bench for it. Let me open my model sim to simulate it and to see whether we can get the correct signal or not. Okay, so this is my model sim, and this is my source code, and this is the model sim folder. Double click it, and we will save the project into this folder. And we new one project here. Click the file, new one project. Close the current project. Okay, so project name is buzzer, and the project location, we can just copy and paste here. Okay, it is here. Okay, so click OK. It will create some folder here. And we added existing file. Added this file and this file. Click OK, close, and compile all to see whether it has some problem or not. Okay, pass the compile. So we do the simulation, start simulation. Click buzzer test bench. Click OK. Okay, it's running. Okay, so here it is. So this is our model simulation interface, and we added all the signal in the region. We added all the signal in the region, waveform signal in the region. Okay, so this is our signal, and we change the simulation time is 10 ms, and we stop run. Okay, it's running. Okay, finish. So we zoom full. Okay, so this is output control signal here, and this is clock. So first things, let's take a look at the clock is 50 megahertz or not. Okay, so we click any one and then zoom in this position. Okay, this is the clock. And we added one more cursor and click here, click any places and click this one. And click here, another cursor, and click this one. Okay, so you can see here, these places, okay, these places, it is 50 megahertz, okay. Between the two yellow lines, this is 50 megahertz, means our input clock is 50 megahertz. And the next, let's take a look at the output. This one, we expect it is 1 kHz. To see whether it is 1 kHz or not. Zoom full, okay. And we click any one. Click this one, any places, and we click this one. This one. And then click another cursor. Click, 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 click. Okay, so let's take a look here. Here. So between the two yellow lines, this is 1 kHz. 1 kHz. It means our code can produce the 1 kHz correctly. Okay, so next step, let's use the 1 kHz to drive our buzzer to see what kind of sound it can produce. Okay, so we need to create our quarters project. Okay, so this is our quarters software, and okay, let me close this model scene first. And we will put our quarters software into this folder, copy it. We can click one new project visa, next. Okay, what's the working director for this project? Okay, we will click this one. And the project's name is buzzer. The name of the top level design entry, so it is buzzer. Okay, so click next, click next, and edit file. We added only one file. It is into this folder and higher level, and this one. Okay, added one file. Click next. We use Cyclone this one and the package QFP and this one and the A speed. Okay, the A speed. So it is this one. Next, next, and finish. Okay, wait a moment. Okay, it finished. So next step, we do the analysis and synthesis. It's running. Okay, it finished. It finished, and then let's take a look at the pin name. Okay, so we needed to assign these 3 pin here. Clock is on our board, and the reset is also on our board. Then this is the the buzzer control pin. So the pin configure is here. Okay, this is our pin config. Clock is this one. We copy and paste. And this is the control pin. Copy and paste. And this is the reset. Okay, and this I/O standard we use 3.3 CMOS 3.3 and 3.3. Okay, so we finished the setting. So that's it. It's very simple. It's very simple. What we need to do is just close it. It will save it by itself. Okay. So next we click the assembler. It will automatically run this place and router. Okay. So just wait a moment. Okay, it passed the compile. So next step, let's take a look at our hardware for the board connection. Okay, let me open my camera. Okay, so this is my connection between our FPGA board. This is our FPGA board, and this is FPGA piano board, which we showed it before. And for this project, we just for this buzzing, to make the buzzer buzzing, we only need to connect 3 pins. So the first pin, this one. So this one is the voltage connected to the 3.3 voltage. This is voltage, and this one is ground. So we shared ground with the FPGA board. So this is the ground pin, and this pin, this is the buzzer control pin. This is the GPIO pin. Here connected to the GPIO 10. Okay, so this is our hardware connection. And the next step, we need to power our FPGA board. We connect the power supply. This FPGA board use one USB power supply, which connect here. So you will see here, this is power LED is turned on. Power LED is turned on. So next, we need to connect our USB blaster. Okay, connect the USB debugger to our computer. Okay, so we plug into our computer. Okay, so next we begin to program the devices. Click here. Oh, we close the video first, and click this one. We can minimize the video a little bit. Put it here. Okay. So Next, we need to program the devices. Click here. Okay, so it is here. So this is our USB blaster. Is the JTAG for the board. Okay, for this board. Okay, so we click this one and start. So you can hear the sound. Actually, pretty louder. Okay. If I press the reset key here, it will stop. Press the reset key on the FPGA board, it will stop. We release it. It will continually produce the sound. Okay. We disconnected the power supply. It will stop the sound. Okay. So that's it. This is this video to make the buzzer buzzing. Okay. So this is Michael, and see you next time.